Today, we face numerous challenges in agriculture. Firstly, we have a growing world population. This means more mouths to feed, and thus we need to produce more food. Secondly, agricultural land is rather decreasing than increasing. So in order to produce this more food, we have to produce more per hectare, more per acre, because we have rather less surface available. Thirdly, we face climate change. This means more dry periods, more irregular weather patterns, precipitation patterns, and this challenges productivity per hectare and yield. And fourthly, agriculture itself is a major emittent of greenhouse gases, especially animal husbandry. So, four tremendous challenges, not only for farmers, but for agriculture and society. And therefore, we need all tools available to develop solutions to overcome these hurdles.
Breeding can offer a lot of solutions to the challenges that farmers and the society have. Classical breeding is based on mutations that happen in nature all the time, and that is a random process. Now, genome editing substitutes this randomness by precision and a very targeted approach. So we basically can decide which mutations are needed and implement them directly into the plant. Genome editing itself is a technology that is taken from nature. And it's the great achievement of the two Nobel laureates from 2020, Jennifer Doudna and Emmanuel Carpentier, that have worked their scientific life studying how bacteria defend themselves against virus attacks. And they found a very simple system consisting of two components that can be used to do these edits. And that is a very fascinating piece of science. These two components are just a simple seeking function, a function that identifies the DNA position that needs to be mutated, and the famous DNA scissor, an enzyme that cuts the DNA at precisely this position, and this is where the mutation happens. We don't want to oversimplify things, and genome editing is a term for actually a very large toolbox of different technologies that have been implemented and are still being researched on by thousands of scientists worldwide. The most used technology of genome editing produces very tiny, small mutations at these precise positions. And that is very close to what happens in nature. Therefore, mutations implemented by genome editing are very similar to what happens in nature. We can call them natural identical. The second beauty of the system is that the components that are used to introduce these mutations are leaving the plants after the work is done. So there's nothing remaining that we add to the plant, and these plants are not transgenic.
So genome editing offers numerous advantages. The most striking feature certainly of this technology is its precision. Secondly, it's relatively easy to apply, so that we can apply it to numerous crops. Thirdly, it offers a time advantage over the methods that we've used in the past. So we can save up to 2 to 3 years in our variety development process, which usually takes about 10 years.
What I really like is that the method allows to take genes from old varieties and put them in one step to our modern high-performing varieties that we have in the market. Starting from improving yield in plants, improving their resistance against pathogens, down to changing the quality of plants. Here at KWS, our customer is the farmer, and we try to show the value to the farmer and to the society. A very recent example where we are engaged in together with 54 breeders in Germany is a project where we use genome editing in order to improve wheat that can withstand fungal disease better. And think about it, if we could substitute one of the usually 3 applications of fungicides, that would already be a contribution to sustainability targets in the European Union, and it would be a contribution to the farmer who earns more because he has less input cost with his system. We are really excited about the opportunities that genome editing delivers, and we really want to show that value to the farmer and the society.
Plant breeding delivers innovations to farmers across the globe. In order to do so as plant breeders in the future, we need access to innovations and technology like genome editing. I think it's a very exciting opportunity to use this precise and speedy tool in order to address the challenges we face.